Welcome back to the Roll-Up High Roller community. As always, nothing on the roll-up is to be construed as financial advice. We are just some educators in the DeFi space. Toss us a quick like, give us a share, a repost, send it to a friend who may want to watch this, and finally, give us a sub or a follow. It means the world to help support credibly neutral educational content in DeFi. We're here to educate, empower, and enrich you, and let's jump in.
What's going on, guys? Welcome back to the Roll-Up. Here today with Miguel from Nillion. We're going to talk about a interesting dynamic when it comes to the differences in scaling using sharding and some MPC, which is a separate type of technology from the typical type of scaling mechanisms that we see in crypto today. Miguel, we're not NPCs, we are MPCs. What's going on, man?
What's going on, Andy? Great to have you to be here with you today.
Yeah, man. So how did you go from being a surfer to being an MPC cryptographer?
It all happened, when I left the Canary Islands, where I grew up. I moved to Madrid and then Munich and then places without waves. So it had to happen. But I did have like my revenge with snowboarding. So it there is still a surfer in me somewhere.
And which is your favorite, boarding or surfing?
I think actually birding. Birding is it's pretty cool.
I think my cousins live in Munich. A little bit off topic here, but this is what the roll-up's all about. It's infotainment. We're going to dive deep, but I'm going to go skiing in the Alps in about a week and a half, so I'm stoked on that. Maybe I'll be thinking about the MPC designs as I'm drawing my lines down the slopes. Yeah. So when did you join the team? Were you there from the beginning?
Yeah, I was there from the beginning. I think the story started back in 2017 when I met Andrew Masanto. He's like a serial entrepreneur, and he's founded a couple of crypto unicorns, Hedera, Hashgraph, and Reserve. And initially we were talking about playing with the idea of creating a privacy coin like Zcash or Monero. But he's got a real good sense for market. And back then he said, no, this is not the right moment for something like this. And then in 2021, we met again in Brussels. I had been working on MPC, multiparty computation. So by the way, maybe I can explain what that is. It's just a way of allowing multiple parties or nodes or computers to compute something together, whereby they contribute private inputs to that computation that are not seen by the rest, and they all get the result from that computation somehow. And so it's a cryptographic protocol. Yeah. And it is it has many applications to crypto, and I had been working on ideas on how to accelerate MPC and make multiplications be more efficient. And so we met in Brussels in 2021 with Alex Page, the CEO of Nillion, and Andrew Yo, the chief marketing officer, and we brainstormed about how to use MPC in the context of decentralized networks, and we got really excited. I mean, with looking at it from different angles, we saw the potential of creating a new technology based on these ideas that would be like a new type of decentralized infrastructure, different than blockchain. We can talk a little bit about the differences if you want. But nevertheless, that provides something else, right? Something new to the space. And in essence, you could summarize it as Nillion being like a secure computation and storage network that decentralizes trust for high-value data, just in the same way that blockchain decentralizes transactions. It's more or less kind of the summary.
So this breakthrough is more focused on secure, decentralized data storage and message passing, and this kind of like transfer of information. And you guys kind of came together in one of these brainstorm, mastermind, how to get rich conversations, and was like, wow, guys, we're going to actually make an impact in this space and be able to kind of put this together. And you guys actually decided to opt away from the typical blockchain space, which was probably kind of, still early when you guys had that conversation. So this breakthrough that you guys have made with MPC, You know, I'd love to kind of learn more how that idea has came from an idea to now kind of what you guys are putting it in practice with alignment with the overall vision.
Yeah. So I think the story can begin with the notion of high value data, right? In a sense, transactions are high value data because they're this is the movement of assets, but they kind of prescribe a certain way of architecting data and compute. For example, data, it has to be immutable because you have this global ledger of transactions, so you don't want to delete transactions. And also you need kind of common consensus on the state of that ledger. So there's a specific type of compute, which is the consensus mechanism, that kind of provides like supports this global notion of an agreement on the state of that ledger. And also the ledger is primarily public. So, but that's not the only type of high value data, right? There's other types that also call for different models. For example, the data model could allow for storage and retrieve and also deletion and updates of the data. That's kind of more similar to what we're used to experiencing in a normal computer. And it also doesn't need to be like like a monolith agreeing on the state of the blockchain, but rather you could have like clusters operating almost independently, just like threads in a CPU. So that's kind of the starting point for this network, to acknowledge the differences compared to a blockchain infrastructure. And once you acknowledge that, then you start designing the different types of networks like DevNet, testnet, and so on. So that entirely mimics what you would expect from a blockchain, but each one of those are very different. We make use of blockchains because it is very useful for certain cases when you need global consensus on certain things and you need to orchestrate the different elements in the network. Then you need a blockchain. But the rest it looks like a clustered network of of different groups of nodes. They operate rather independently, and each one of them kind of serve. They perform computations on behalf of the users on data that is kind of stored privately, so it's not in the clear. It's not like in a blockchain, and provides like the answers for those computations back to the users or whoever needs them.
And so this is something that you guys came up with and have drawn up with in different technical papers over the last couple of years to kind of come up with these answers, right? And I know that you guys are working on one now as well, which I have this feeling that you guys are just never going to stop working on papers. It's just going to keep on going until you guys are like, all right, we're done, which who knows? But yeah, so what is the current paper that you guys are working on now that we've established this foundation of what kind of the vision and what the operational capacity of Nillion is? Where are you guys looking to go now with your upcoming paper and kind of research?
Yeah, so I agree with you that this is a never-ending story of papers. It's never going to end up. And so far we've been focusing on development on developing the core infrastructure. So we've been a little bit shy on showing the work to the rest of the community. So now we're really excited because there's a time where we've hit a time where we are going to change that, and we're going to start publishing a number of papers, beginning with the first one, which is essentially about that core technology I was talking about. Is one of them, by the way. We have also other different technologies, but this was a foundational one, and it's about essentially how to do MPC with multiplications in an efficient way. So any computation that you can think of can be boiled down to additions and multiplications. Additions are typically performed by MPC protocols very efficiently, but multiplications typically require the nodes to exchange information. And so this technology allows you to do certain number of multiplications and additions for free, like without communication. And in doing so, it provides a really efficient and fast way of doing things. And you can use it for things like authentication, signatures, private database, retrieval of information, all those things that are not too big in terms of computation, but that require that are very time sensitive. So they need to run very fast because there's a user waiting for that, and users are kind of used to certain standards in terms of, for example, authentication. They cannot wait there for 10 seconds. It has to be fast. So it is a technology that enables all those use cases. And following that, we've already published all these two papers I've been talking about. So one is the authentication. That paper is important because if you think about decentralizing, you have high value data. You don't want to give it to one server, to one company, because they have full control of it. So the natural thing to do is decentralize it, right? So you break it into bits. Every bit is private, so they cannot gain any information from that single bit. So that's good. But next comes the problem of accessing that data. So you need a data access structure that is also decentralized, because if you rely on centralized authentication against a single server, then that single server has your key that can access all the data. So you need to decentralize authentication, and that's a bit tricky. So we've published this paper that looks at the problem from different angles: the legal angle, the engineering challenges, and also the cryptographic protocols that are based on the previous one I mentioned. So that's this other paper. And then there's another paper on signatures, which is, again, a very interesting problem. Like, okay, you're signing transactions, sending them to the network. That private key controlling those signatures is really important. So what do you do with that? Do you store it like in your computer? Probably not a good idea. Do you keep it offline on paper? Okay, that's better, but still it has problems attached to that. So MPC solves that, because it allows you to decentralize that key. So you can break it into pieces, give each piece to a different node, and now no one has all the information to reconstruct it, but you can still instruct the network to sign on your behalf. So there's a number of companies already in this space. I think it's kind of the main use case for MPC technology right now. And we thought about, okay, why don't we use this core technology I was talking about and see how it performs when we apply it to signatures. So that's this paper. And it's a technical report. It's not a full-blown mathematical paper, but it does present protocols based on this core technology. And the main feature is that it reduces the number of rounds of communication to the bare minimum, which is, I need one to send you the hash of the message and to get the signature back. That's it, 2 messages. And the rest of the signature computation is local. And it also has more like technical advantages that are maybe not for this audience.
Yeah, we're getting into the technicals, but I'm curious about it, because with these with MPC, what's coming to my mind with what you're saying, which it all sounds extremely efficient and effective for decentralization of data, for storage of data, for transfers, for secure passing of information and data. But a question that I have is about the incentive structures. And perhaps you could give us a practical example of how you see this technology with what you're building being either implemented today or planned implementation, and I'll give our audience a simple example where in proof of stake models on blockchains, the actors put up their stake, their coins, their assets, and they can get slashed if they act outside of the network, or if they try to do something, kind of in bad intent, they can, they get penalized. So there's this kind of like incentive design, super basic, right? There's tons more incentive designs in blockchains and in computers. But with Nillion, with MPC, where is the incentive structures aligned for these different nodes and people or entities or servers who are acting within the network to kind of in these protocols that you're explaining, and like kind of abide by the bounds of what the ideal kind of structure is in this decentralized fashion? Is there a monetary incentive? Is there like a penalty? Is there some sort of idea that we can understand from a practical level as to how this works in the incentive design level?
That's a great question, by the way. So MPC is not proof of stake, but there is staking. So the way we're implementing it is we require the nodes to put up stake, and also we build control mechanisms that allow to identify situations where the nodes are acting in a malicious way. And that is slightly different than what happens in a blockchain. So in MPC, you can act primarily in two main bad ways. So the first one is you follow the protocol, so there's no way to really detect you, but you're silently leaking those pieces of information you're getting from the users. So you're sharing that information, with the other nodes, with the hopes of gathering enough information to reconstruct the data. Those are called passive adversaries, and actually they're hard to detect because they follow the protocol. So there's not an easy way to detect them, but you can place both like incentives for those nodes to report if there's another node approaching them with those intentions, and also, of course, the staking that once that is reported, then you get slashed, and then you're penalized by doing that. So you can address that from the token economic perspective. There's also ways in which you can address that from a more cryptographical sense, which is to use encryption so that those shares are never in plain text. So that's, for example, what we use for the signature paper. So the shares or those bits of information are actually encrypted. So even if you gather them all, you will still have to find the private key to decrypt them. So that's a kind of full, another layer of protection. But then you have the other type of adversary, which are active adversaries, which is the Byzantine adversary you're used to from blockchains. Those are the ones who deviate from the protocol in any way or form. And they just want to, in our context, what they can do is change the result from a computation. Not in a predictable way, but they can make it like produce random, gibberish. But those are, interestingly enough, those are easier to detect because you can build in mechanisms into your protocol that have, by the way, the same ratios of like up to 1/3 of the nodes can be bad actors, and you get Byzantine full fault tolerance and stuff like that, because the underlying mathematics for both Byzantine agreement and MPC computations are the same. So you get the same kind of trade-off. And then you can identify those nodes. So you can detect, there's 3 levels of protection here. Number 1 is you detect that something went wrong, and then you abort. Number 2, you get even better, and you can also identify the nodes who were bad actors, and you can slash them. So that's the minimum level we're interested in, because that's the one that allows you to slash. And then the 3rd level is where you can even correct the bad actions introduced by those nodes. So they can send wrong messages and stuff like that, but as long as those are within a certain ratio, you can actually correct them because there's enough redundancy in the network to do that.
Gotcha. Okay, and then in Nillion's case, I guess also in other MPC networks, is the stake simply software and tokens, or is there also hardware involved?
It's primarily software. This is in tokens. Gotcha. And also we see like path to decentralization. Like we are not building from day one the full-blown security model that I just described. We're going to go from a scenario where the initial nodes are more trusted to progressively adding those mechanisms to detect bad actions, and to progressively add more permissionlessness into the network so that the onboarding process of the nodes becomes more and more relaxed. That's kind of the goal.
Yeah, okay, gotcha. Yeah, that kind of is the reason why I put sharding maxi in my stub name here, because in the previous conversation that we had with one of the lads from Nillion, it was directed around sharding. Now, was that a previous paper and kind of focus, and that it's shifted, or is that still tying into kind of how you see MPC and Nillion playing out? Like, is this distributed technology of data also a form of like sharding, in the sense where there's different nodes and different pieces of data separated amongst all of the nodes that makes the whole? Is that how we think about sharding in this sense, or is that just something that we're not really focused on anymore?
In a sense, how the way data is protected in MPC resembles sharding. Like you are breaking down information into pieces. Those pieces do not, and you need a minimum number of pieces collected to be able to reconstruct the information, and you distribute those pieces among the nodes in the network. So it kind of resembles a little bit what you're describing, but well, formally speaking, it's called a threshold linear secret sharing scheme. So it's a way of breaking down information into pieces, and if you cross a threshold, meaning you get more than a certain number of pieces, then you can reconstruct. But if you don't, then you can't learn anything from the data.
Right. It's like going to the bank or it's like giving half your private key to your mom, the other half to your dad, and saving one word for yourself.
Exactly.
Two examples that come. Wait, go ahead.
Yeah, if they collude and they don't get this critical number of pieces, then there's nothing they can do. It's just as good as if they hadn't colluded at all.
Right. And then obviously the incentive structure will be aligned so that doesn't happen. That's more of like the in that example, that's more of the passive adversary. Or
exactly. Yes.
Gotcha. Yeah, makes sense. And again, that doesn't make any sense for people to do necessarily unless the validator count is very low, where in the beginning you'll have trusted validators, likely people, perhaps investors, trusted people that KYC and things. But eventually there's a world where permissionlessly anybody can be a validator however they want. They just need the required stake. So I assume that'll kind of open up the strength of the network more and more to where it scales somewhat exponentially as you add validators. I'm curious if you know, or if you've heard much about like EIP 4844, where it's proto-dank sharding on Ethereum, where they're separating the blobs of data from the transactions of the on Ethereum. And this has just got me thinking, kind of similar to where you guys are, where it's like separating obviously from blockchains, but just kind of focus on the data aspect. Yeah. I just bring it up because it's coming soon, but it's something that's interesting.
Yeah, there are again similarities to the structure of our architecture, which is based on clusters. We call them clusters, and each cluster is operating on a like a segmented way of segmented subset of the data. So the whole data on the network is actually divided in segments that are assigned to the different clusters, and within a cluster you can do whatever you want with the data within that cluster. And in a sense, this achieves certain degree of decentralization along the logical axis that Vitalik describes, like he described the three axes of logical decentralization, architectural, and political. Blockchains typically just achieve the two of them, like architectural and political, but this one is going a little bit on the other direction as well, because to a certain extent, the operation of those clusters is fairly independent. So you can slice the network in two, and now you have the clusters divided in two, but that still can function to a certain extent because of that division of data that you were mentioning precisely.
Yeah. Another kind of because a lot of the stuff that I've been learning about on the modular and the rollups and the Ethereum side, I'm drawing similarities here. So bear with me as I draw another one. A big concept right now, distributed validator technology in Ethereum. Basically, it's been expensive to run nodes. You have to 32 ETH. Rocket Pool, Lido came around. You can just do liquid staking. Now they're taking that even further, where you can run like a solo staker node, which is 1, 3 ETH, 4 ETH, and basically what happens is these validator keys get split into however many parties there are in that 32 ETH. And so similarly, I'm curious about the barrier to entry to become a node in Nillion, if it's going to be if it's a set value, or if it is dependent on the token price, or kind of what that even looks like. And then is there a thought about like how you can potentially democratize that as well, and like offer let's say smaller players to be able to participate in the network without necessarily needing to buy the whole node or to own a whole node?
Yeah, good question. So the detail of the token economics have not been figured out yet, so we haven't defined them yet. In my head, there will be like a minimum staking requirement for nodes to join. But it's an interesting thought what you're mentioning, that actually what is a node behind the scenes could be like a network of smaller parties,
like clusters,
clusters, kind of sitting behind. It's like a logical abstraction of that level of detail, and for the network it just behaves as a node, but under the
And
hood.
there's advantages too. I mean, the advantages become that node could then be shared amongst, half a dozen different geographical regions, right? Further enhancing the decentralization of that node, thus the network. And then you can allow more people to get in. I just think lowering the barrier to entry for any distributed proof of stake, or just any distributed MPC network of information data value is like it's huge. For,
The only thing we have to be careful about is Sybil attacks, essentially. So those little nodes, if they get all the information from their logical abstraction, the chances, because their staking is lower, the chances that they collude with others without being economically sufficiently penalized are increasing. So, but I agree with you in that it should be easy. It should be dead easy to join a network, and it should also be kind of relatively affordable so that almost anyone can run nodes. Another thing you can do is trust. Like the nodes are not like anonymous, but they are meaningful to you. So maybe you mentioned like half jokingly your parents and your brother, your sister, the people you would trust your sensitive information with. Those could could form a network or a cluster that is the cluster actually taking care of your data. So there's not just like random anonymous nodes. They mean something to you. There's certain social bonds to them, and trust liaisons, and that offers additional security in that sense. So that's another way in which things could be made cheaper and still without compromising security.
Yeah, I mean, the more and more I kind of understand the idea here and the vision, the more and more I just think about like this private internet, this decentralized web, this kind of trying to disrupt these adversaries, or you could even I view them as adversaries because I'm so deep down this rabbit hole, but the common folk, just views them as like tech companies, like the Facebooks and the social medias and all just like the internet clusters, if you will, that exist. I mean, the vision for you guys probably has shifted since when you started, but if it has, could you maybe shed some light on where you see the best and most valuable product market fit kind of implementation of this technology that you're building? And perhaps like if you have anything like that's under wraps or kind of like planned maybe, or you can maybe at least give us a direction as to where you see this kind of going, like where do you guys make a change or impact or implementations in the internet that we know it?
I think there's like two main avenues that we are exploring. One is taking the current state of Web3 and trying to remove like or unleash its potential for growth. Because if you think about, like, there's been already like more than 10 years since it was created, and it hasn't replaced Web2 entirely. One of the reasons is because there's limitations, as I was explaining before, as to what you can do in terms of data access control and in terms of computational model behind the Web3 technology. So in expanding and making them more flexible, those two models, we hope to make it feasible to kind of broaden the use cases that we're seeing with Web3 to the point where they start permeating through actually Web2 use cases. And the other way to look at this is from the other angle. Like, okay, we have Web2, we have barriers into entering a Web3 ecosystem, because essentially Web3 is missing a key component, which is the ability to keep information confidential. And Web2 without confidentiality is almost nothing. So from that other perspective, there's companies and use cases in Web2 awaiting to be decentralized, but they're hitting this blocker of confidentiality. And MPC technology could be an enabling factor that would enable, would remove that blocker essentially, and would enable Web2 use cases to be decentralized as well.
Yeah, it's interesting. So there's possibilities to somehow integrate with blockchain-based applications, regardless of where they are, and implement this MPC technology at like the foundational data level.
Yes, and in fact, every Nillion node is also a blockchain node. So it's also layer 2 blockchain node. So there is a very close interaction between the two concepts, to the extent that nodes are bilingual, so to speak. And you can open up all those use cases that involve the exchange of assets on a blockchain, but as well some sort of computation that requires decentralization, but also handling other high value data that is not just transactions.
Yeah.
Authentication would be one use case. Like, okay, you have this information, which are the authentication factors, like something your biometric information, your password, all that information that is not exactly a transaction, but you can do an MPC computation that allows you to authenticate to a blockchain network, which now allows you to then send transactions, sign transactions.
Gotcha. Yeah, it makes sense. It's like the other part of, not the other part, but it's the aspect that we honestly don't even see when interacting with blockchains. It's kind of just like you sign in with your wallet or with whatever data you have, and you're just so used to it, you just start transacting. You don't even really think about that, but like that foundational level has a mass market to be able to kind of apply to.
Or take, for instance, interoperability, right? So instead of just moving assets from one blockchain to another one, you could move messages or information, but also with processing in between. So you could add some, additional information that is high value from the outside world and mix all together in one computation that now moves one event from one blockchain to another one. The use cases are really vast in that sense.
Yeah. So are there other MPC blockchains or MPC networks that you know of that have tokens today? And are they running on, like, is the token native to that MPC network, or is it like a different type of token standard? Or how does tokens work when it comes to MPC?
Yeah, so tokens are not MPC are not an MPC native thing. So you don't run the token in MPC because, as I said before, like we should use blockchains for whatever they're best equipped for, which is token management. So typically they sit along along the MPC network, and in our case, we will probably start with an Ethereum-based token, ERC20 or the likes of it. But there is also value in deploying your own token because you have more control over governance. You get fewer fees and stuff like that. So there's other projects out there. They present different flavors of multi-party computation, like based on fully homomorphic encryption or based on more standard linear secret sharing. And some of them don't have tokens, so it's not a must-have in this space, but some of them do, and they do what I just described. So they have like a normal, regular blockchain token, usually on Ethereum, and that's kind of tied up to the value of offered by the network.
Very cool. Yeah, that was a bit of a blank spot for me there. But I think I have a pretty wide and also pretty deep understanding of MPC from at least the abstract and high level. Obviously, the cryptographer aspect is quite different. And kind of as we come to a close in the coming minutes, you've got a cryptography background, also founder. Your team members are some serial entrepreneurs. I'm an entrepreneur. There's builders in our audience, a lot of developers, builders, tons of DeFi users as well. What's kind of some thoughts that you have for early stage founders, whether they've raised or not, and whether they, are engaged in cryptography or are, just doing other types of programming and building cool stuff? What are some words of wisdom that you can share with our audience as far as maybe getting off the ground, finding product market fit, having grit and kind of perseverance to see your ideas come through, team, these types of things?
Okay. I think one of them would be that you need to deepen your knowledge on cryptography because it's becoming more and more prevalent in every Web3 project. So understanding what, not just hashing, which is the basics, but also what zero knowledge proofs are, and also other things like fully homomorphic encryption and MPC. You have to stay updated because this is a really changing environment. So, following some leaders in the space would be a good idea, participating in conferences and all that. I would also recommend to focus on security from day one, as in it's not an optional thing in Web3. It's really important. It's foundational, even though it's a non-functional requirement, but it's a very important one. I would also consider engaging with community from a very early stage, because Web3, the ethos is about building with the community. It's not just like a private company and the rest are customers. It's like they have a piece of your company if they hold tokens, so they are like part of you. So embracing that from the beginning, I think, is very important. And open source is part of that. I would also focus, like you said, on product market fit, on use cases. That's probably not the case for every crypto project, but it should start being like the norm, I think. Focus on real product market fit. Focus on user experience as well. It's something that is not always that good in crypto projects. So still, user experience is not like is only geared towards certain people with certain skills. So it's not like embracing a wider audience of users. And I think I would also care about regulations. They haven't been that important yet, but I think they're coming. And it's a muddy and tricky space, because sometimes they're not clear about what they mean to crypto, right? They just regulate Web2 centralized environments, but it's not really clear how to apply them to crypto. So having someone in your team with that knowledge, I think, would be a great idea. And maybe embrace the ethos of decentralization. I think you really have to believe in what it means and represents. Otherwise, if you don't do that, it feels like you're making a hard time for yourself, because implementing something as simple as, for example, authentication in a centralized setup becomes suddenly something that is really complex in a decentralized setup. So if you don't really believe that you're doing that for a very good reason, then it doesn't make any sense to complicate life for yourself.
Yeah, I appreciate that, and some valuable insights for the broader community at whole, developers, founders. So thank you, Miguel, for your time, and excited to see the vision of Nillion come to play, and stay up to date.
Thank you, Andy. It was great talking to you, and for everyone listening, remember that if you want to check out the papers, you can find them pinned in our Twitter. And happy to join the conversation.
Awesome. Thank you.
Thank you.